and we are going to learn what the difference is between the word verify and the word prove. So we've been proving already. Proving is what we've been doing where you've set up your left side and set up your right side, and it's a puzzle to get them to equal each other. And when you prove an identity, you've proven it for every single value of theta possible. The only values that it wouldn't work for is if they're non-permissible values that cause you to divide. But any value that's possible, it now works for everything. So a proof is very powerful because it says that I now know that this works for any value. I don't even have to check anything else. A verification is just one specific value. So it shows that something works, but it doesn't necessarily mean that they all work. So a verification isn't nearly as powerful as a proof, but sometimes when you are checking things and you're checking a specific number, you notice something and then you wonder, oh, I wonder if that always works, or if it was just happened to work only for that value. So what we're going to do for each of these is we're going to verify them for 30 degrees, and we're going to prove them. Now, the work for verifying and proving is very similar. So to verify, again, we write out the left side of your equation and the right side of the equation, and we put a line just like we do with a proof. The only thing different in a verification is we actually plug in the value. So here I would have secant of 30 degrees times by 1 plus cos of 30 degrees. That's what's on my left side. And on my right side is 1 plus secant of 30 degrees. So you'd have to go to your pie plate and figure out each of these. What is secant of 30 degrees? Well, cos of 30 degrees is root 3 over 2. So secant of 30 degrees will be 2 over root 3. And then you would have 1 plus, and cos of 30 degrees is root 3 over 2. And on the right side, we would have 1 plus secant of 30 degrees is 2 over root 3. So in a verification one, it's like a proof in that you still need to make the left side equal to the right side to verify it, but now you're working with actual numbers and just have to use your fraction skills. So in order to get these equal, we're going to try to write both sides as a single fraction and simplify that fraction so that the fraction looks the same. So on the left side, can you see that if I wanted to get rid of the brackets, I could distribute? If I distribute, I'm going to get 2 over the square root of 3 plus 2 root 3 over 2 root 3. And what is 2 root 3 over 2 root 3? 1. And that's going to work out very nice for us, isn't it? Because as soon as I simplify that, are they identical at this moment? Yes. Therefore, the left side equals the right side. We've demonstrated what we were asked to show. Very nice. So that is a verification. For a proof, let's try to prove this one. So again, we write out that we have secant theta 1 plus cos theta on the left side and 1 plus secant theta on the right side. What could we do? What could we change? Yes? Mm-hmm. When you distributed it and wrote 1 there, that would be fine. That would be something that they could say, yes, I can see where they went with their mental math. When you're proving or when you're verifying, you don't want to skip too many steps. So for example, in the proof here, it would be frowned upon if you went, oh, I'm done. Well, what did you do? Oh, I just did it in my head. Well, no, I think a little bit more work would need to be shown. Okay? And also, do not, on your quizzes or on your tests, if you don't know how to make them equal, just leave your work where it was at. Don't invent something. You're like, oh, I am so stuck, scribble, 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 done. And you just write the other side, so you feel like, just write the other side at the bottom, and then it looks like you finished. Because you can actually, you might have gotten 2 out of 3 with your work up to that point, but then writing them the same may have made a mistake, and then you would lose an additional mark for that mistake. So you had 2 out of 3, and then you tried to smudge it, and you end up getting worse. So, okay. So for this proof, there are many different ways that you can do a proof. What would you like to start with? What can you see? What could you change? You can change secant to 1 over cos. And you're going to notice that as you do these questions, do you want to change this one to 1 over cos as well? Or do you want to leave that one as secant? Change it? Okay. You're going to notice that for every single proof, one of the strategies that often works is changing things to sine and cosine. Because you can change everything to sine and cosine. Right? Secant, 1 over cos. Cosecant, 1 over sine. Tangent, sine over cos. Cotangent, cos over sine. So all of them can be changed to sine and cos. And so sometimes, and a lot of times, that's going to be a strategy that's going to help you. Sometimes that strategy makes your proof longer. And then we'll look at some times where, oh, there's a strategy that would have made it quicker, but it's often a very good strategy. Okay, so we've changed things to cos. And we've got cos on both sides, but they're not equal yet. What would you like to do next? Distribute. So if I distribute this, I'm going to get 1 over cos. And what is 1 over cos times cos? 1. Therefore, left side. Nice. And there's our proof. For the second one, do you want to verify that one and prove it on your own? Okay? If you get stuck, call me over. Oh, and the questions you can do are 3, 5, 6, and 7II.